second lecturing session on the module 3 internal combustion engine in the subjects elements of mechanical engineering. I am Krishna Prasad S, assistant professor from the Department of Mechanical Engineering, MIT Mysore. In the previous session, we have discussed with some of the important topics in the internal combustion engine called introduction, then types of internal combustion engine. Under that, there are two types, external combustion engine and internal combustion engine. Then later we are also studied with what are the main components of the internal combustion engine and IC engine terminologies. Okay, in today's class we are continuing with the next topic. It is called working principle of 4-stroke petrol engine. Okay, before going to the understanding of working of 4-stroke petrol engine, again we need to recall what are the important components of the internal combustion engine. Okay, so the most important components of the internal combustion engine, under the very first one, it is called as the cylinder. So what is meant by the cylinder? The cylinder, it is called as the heart of the engine, inside which fuel is going to burn and power is going to develop. Okay, and in order to withstand very high pressure and high temperature developed due to the combustion of the fuel inside the engine cylinder, this engine cylinder, it is usually made up of high strength materials like cast iron or mild steel material. Okay, next, second one, what is meant by the piston? The piston, it is called as the movable component inside the engine cylinder, or it is also reciprocates inside the engine cylinder due to the combustion of the fuel takes place inside the engine. Okay, once the combustion of the fuel takes place inside the engine cylinder, then burnt gases are produced. These burnt gases are expands and exerts a large force on the movable component called piston. That's why it is going to reciprocate inside the engine cylinder, and the motion from the piston, it is transferred to the crankshaft through these intermediate mechanisms like connecting rod and the crank. Next, third most important component in case of the engine cylinder, it is called piston ring. What is meant by the piston rings? Piston rings are the metallic rings inserted into the circumferential grooves provided in the top end of the piston. Okay, there are two types of piston ring. The one, it is called compression ring, other one, it is called oil ring. Here the compression rings are going to maintain the gas tight joint between the piston and the cylinder. That means whatever the burnt gases are produced because of the combustion of the fuel should not escape and enter into the crankcase, because in the crankcase we are placed the engine oil that should be used for lubricating all the parts of the engine. That's why we need to maintain the gas tight joint between the piston and the cylinder. That's why we need to use the compression ring. Next, oil ring. The oil ring, it is going to extract the excess lubricating oil and send it back to the oil sump through oil holes provided in the oil ring. Okay, so that is very much important. Then fourth one, it is called connecting rod. The connecting rod forms a link between the piston and the crankshaft. Okay, and the connecting rod having the two ends, the one it is called smaller end, other one it is called larger end. Here smaller end of the connecting rod, it is connected to the piston through piston pin, and the larger end of the connecting rod, it is connected to the crankshaft through crank. And the main function of the connecting rod is to convert the reciprocating motion of the piston into rotary motion of the crankshaft. Then crank. Crank is a lever that is connected to the connecting rod at one end and a crankshaft at the other end. Okay, next, crankshaft. The crankshaft is the rotating member. It is used to drive the various other parts of the vehicle after it is receiving the power from the piston due to the combustion of the fuel. Next, flywheel. Flywheel is the heavier wheel mounted on the crankshaft of the engine. That means it stores the energy during the power stroke and supply the same energy during the other three strokes like suction stroke, compression stroke, power stroke and exhaust stroke. Okay, next, inlet and exhaust valve. Inlet and exhaust valves are going to control the entering of air fuel mixture into the engine cylinder through inlet valve, and exhaust valve, it is used to expel out the exhaust gases or burnt gases from the engine cylinder to atmosphere. So these are the main components of the internal combustion engine. Now we are entering into the today's topic. It is called working principle of 4-stroke petrol engine. Okay, here the petrol engine, it is works on the basic principle of Otto cycle, and this Otto cycle, it is also called as the constant volume heat addition cycle. Okay, I will repeat here, the 4-stroke petrol engine, it is also called as the Otto cycle, and the Otto cycle, it is nothing but it is a constant volume heat addition cycle. And why it is called as the 4-stroke? Very simple, here working cycle of the engine, it is completed in 4 different strokes, that is called suction stroke, compression stroke, power stroke and exhaust stroke, as well as during the 4 strokes of the engine, crankshaft it is going to rotate twice. That means your working cycle completed in 2 revolutions of the crankshaft, that is called 0 to 720 degree. Okay, now we will come into the first stroke of the engine, that is called suction stroke. So what are the things we need to remember during the suction stroke? That is very much important. During the suction stroke, inlet valve is open and exhaust valve is closed. Okay, I repeat, during the suction stroke, inlet valve is open and exhaust valve is closed. And during the suction stroke, piston moves from top dead center to the bottom dead center. Okay, due to the downward moment of the piston, suction it is going to create it inside the engine cylinder. Okay, due to the downward moment of the piston, suction is going to create it inside the engine cylinder. So because of this, a fresh charge of air petrol mixture enters into the engine cylinder through inlet valve. Okay, I repeat, due to the downward moment of the piston, suction it is going to create it inside the engine cylinder. So because of the suction, a fresh charge of air petrol mixture enters into the engine cylinder through inlet valve. Once the piston it is reaches the bottom dead center position, suction stroke ends, and during this moment, crankshaft rotates 0 to 180 degree. Okay, during the suction stroke, crankshaft rotates 0 to 180 degree, and the suction stroke it is represented by line AB in the PV diagram. Okay, so this is regarding to the suction stroke, and this position it is called as the end of the suction stroke and the beginning of the compression stroke. Okay, what happens during the compression stroke? Very simple. During the compression stroke, both inlet and exhaust valves are closed. Okay, during the compression stroke, both inlet and exhaust valves are closed, and the air fuel mixture it is already filled inside the engine cylinder during the suction stroke. Okay, so during the suction stroke, air petrol mixture it is already completely filled inside the engine cylinder, and during the compression stroke, the piston moves from bottom dead center to the top dead center. Okay, during the compression stroke, piston moves from bottom dead center to the top dead center, and due to the upward movement of the piston, high pressure and high temperature it is going to create it inside the engine cylinder. Okay, so due to the upward movement of the piston, here the air petrol mixture is completely going to compress, and high pressure and high temperature it is going to create it inside the engine cylinder. Okay, and the compression stroke it is represented by line BC in the PV diagram. Okay, as well as, and at the end of the compression stroke, the volume remains constant for the small displacement. Observe here, at the end of the compression stroke, the volume remains constant for the small displacement. So this position it is called as the beginning of the power stroke and ending of the compression stroke. Okay, so that means at the end of the compression stroke, volume remains constant for the small displacement, hence CD represents the combustion at constant volume. Okay, here BC considered as compression stroke and CD represents the combustion at constant volume. Okay, next, third one, it is called as the power stroke. Okay, what happens during the power stroke? During the power stroke, both inlet and exhaust valves are completely closed, and at the beginning of the power stroke, the spark plug ignites, and whatever the air fuel mixture present inside the engine cylinder is going to ignite, hence high pressure and high temperature is going to develop, and this pushes the piston from top dead center to the bottom dead center. Okay, I repeat, during the power stroke, both inlet and exhaust valves are completely closed, and at the beginning of the power stroke, a spark plug ignites the air fuel mixture present inside the engine cylinder, hence high pressure and high temperature is going to create it. This pushes the piston from top dead center to the bottom dead center, and during the power stroke, crankshaft rotates 180 to 270 degree, and during the compression stroke, it was crankshaft rotation from 180 to 360 degree. Okay, so that means now during the power stroke, crankshaft rotates 180 to 270 degree as well as piston moves from top dead center to the bottom dead center position. And at the end of the power stroke, exhaust valve is open. Okay, at the end of the power stroke, exhaust valve is open, hence sudden drop in pressure is going to take place. Observe here, this is the end of the power stroke and beginning of the exhaust stroke. Okay, here line DE represents the power stroke and line EB represents the sudden drop in pressure. Okay, here line DE, it is called power stroke, and line EB represents the sudden drop in pressure. Okay, so last, what is meant by the exhaust stroke? Observe here, at the exhaust stroke, here inlet valve is closed and exhaust valve is open. Okay, so and during this moment, piston moves from bottom dead center to the top dead center, and due to the combustion of the fuel, whatever the burnt gases produced like carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen dioxide, this is all going to expel out into the atmosphere through exhaust. Okay, and at the exhaust stroke, crankshaft rotates. Crankshaft rotates 540 to 720 degree, and during the compression power stroke, it is 360 to 540 degree. Earlier, I was written mistake. It is 180 to 270, but it is 360 to 540 degree, and during the exhaust stroke, it is 540 to 720 degree. Okay, I repeat, what happens during the exhaust stroke? So, at the exhaust stroke, inlet valve is closed as exhaust valve is open, and piston moves from bottom dead center to the top dead center, and due to the upward movement of the piston, whatever the burnt gas is present inside the engine cylinder, it is going to expel out through the exhaust valve into the atmosphere, and exhaust stroke, it is represented by line BA. Okay, this is considered as the working principle of 4-stroke petrol engine. I repeat, what happens during the suction stroke? During the suction stroke, inlet valve is open and exhaust valve is closed, and piston moves from top dead center to the bottom dead center. Due to the downward movement of the piston, whatever the air fuel mixture present inside the carburetor, it is enters into the engine cylinder through inlet valve. Okay, then once the piston reaches the bottom dead center position, suction stroke ends and inlet valve is going to close, and suction stroke, it is represented by line AB in the PV diagram. Next, second one, compression stroke. During the compression stroke, both inlet valve and exhaust valves are closed. Piston moves from bottom dead center to the top dead center. Due to the upward movement of the piston, air fuel mixtures are going to completely compressed and pressure and temperature is going to increases. And at the end of the compression stroke, volume remains constant for the small displacement. Okay, here line BC, it represents the compression stroke, and line CD, it is called as the combustion at the constant volume. Then power stroke. So at the power stroke, both inlet and exhaust valves are closed. Then at the beginning of the power stroke, spark plug ignites and air fuel mixtures are completely going to burn, hence high pressure and high temperature is going to created. This pushes the piston from top dead center to the bottom dead center. Okay, and here the moment of the power stroke, it is represented by line DE in the PV diagram. Okay, and at the end of the power stroke, exhaust valve is open, hence sudden drop in pressure is going to take place, hence line EB represents the sudden drop in pressure. Okay, then last one, it is called as the exhaust stroke. So in the exhaust stroke, inlet valve is closed and exhaust valve is open, and the piston moves from bottom dead center to the top dead center. So due to the upward movement of the piston, whatever the burnt gases present inside the engine cylinder, it is expelled out through exhaust valve into the atmosphere, and line BA represents the exhaust stroke. So this is called as the working principle of 4-stroke petrol engine. Welcome back, students. The second topic regarding to the today's session, it is called 4-stroke diesel engine. As compared to the 4-stroke petrol engine, here the working of the 4-stroke diesel engine is also same, but some of the components regarding to the 4-stroke diesel engines are different, as well as the thermodynamic cycle and the PV diagram, it is also going to changes regarding to that. Okay, so what is mean by the 4-stroke diesel engine? Okay, so 4-stroke diesel engine, it works theoretically based on the diesel cycle. Okay, so it is works theoretically diesel cycle, and it is also called it as constant pressure heat addition cycle. Okay, it is called it as constant pressure heat addition cycle. And again the same, why it is called as the 4-stroke, that means here the working cycle of the diesel engine, it is completed in 4 different strokes, that is called suction stroke, compression stroke, power stroke and exhaust stroke. Also here, in order to complete the one working cycle, crankshaft have to rotate for 2 revolutions. Okay, that means 0 to 720 degree. Okay, so again the same, what is the first stroke in case of the 4-stroke diesel engine? Okay, so the first stroke, it is remains the same, that is called suction stroke. That means during the suction stroke, inlet valve is open and exhaust valve is closed, and during the suction stroke, piston moves from top dead center to the bottom dead center, and due to the downward movement of the piston, here the suction is going to created inside the engine cylinder, and due to the suction, in case of the diesel engine, only air enters into the engine cylinder through inlet valve. Okay, very simple. During the petrol engine, both air and petrol mixtures are enter into the cylinder through inlet valve, but in case of the diesel engine, the difference, it is called here only air it is enters into the engine cylinder through inlet valve during the suction stroke. Once the piston it is reaches the bottom dead center, the suction stroke it is going to end, and during that movement the crankshaft rotates 0 to 180 degree. Okay, and here the line AB, it is called it as the suction stroke in the PV diagram. Okay, I repeat, what happens in the suction stroke? Here the piston moves from top dead center to the bottom dead center, inlet valve is open and exhaust valve is closed, and due to the downward movement of the piston, suction is going to created inside the engine cylinder, and only fresh air it is enters into the engine cylinder through the inlet valve. Once the piston it is reaches the bottom dead center, then suction stroke ends and inlet valve is also getting closed, and the crankshaft rotates during the suction stroke, it is 0 to 180 degree, and line AB represents the suction stroke in the PV diagram. Okay, the line AB, it is called suction stroke. Next, second one, it is called compression stroke. What happens during the compression stroke? During the compression stroke, first one, it is called both inlet and exhaust valves are closed. Okay, both inlet and exhaust valves are closed, and the piston moves from bottom dead center to the top dead center. Okay, whatever the air present in the engine cylinder, what happens now? It is going to compress. Okay, due to the upward movement of the piston, whatever the air present inside the engine cylinder is going to compress to high pressure and high temperature, and at the end of the compression stroke, here the pressure it is remains constant for the small displacement. Okay, at the end of the compression stroke, the pressure is remains constant for the small displacement, and during the compression stroke, crankshaft rotates 180 to 360 degree, and here the line BC represents the compression stroke, and line CD represents the combustion at constant pressure. Okay, I repeat, here the line BC represents the compression stroke, and line CD represents combustion at constant pressure. Okay, so this is regarding to the compression stroke, and during the compression stroke crankshaft rotates 180 to 360 degree. Next, power stroke. What happens during the power stroke? During the power stroke, both inlet and exhaust valves are closed, and at the beginning of the power stroke, here instead of the spark plug, now fuel injector it is placed, okay, and this fuel injector spraying the diesel into the hot compressed air, okay. So at the beginning of the power stroke, fuel injector spraying the diesel into the hot compressed air. Once the diesel comes contact with the compressed air, it is going to burn, hence high pressure and high temperature is going to develop, that pushes the piston from top dead center to the bottom dead center, okay. So due to the downward movement of the piston, here crankshaft it is going to rotate from 360 to 540 degree, and whatever the flywheel present on the crankshaft, it is going to store the energy and it supply the same energy during the suction stroke, compression stroke and exhaust stroke. And at the end of the power stroke, exhaust valve is going to open, hence sudden drop in pressure is going to take place, okay. Here line DE represents the power stroke, and line EB represents the sudden drop in pressure. And during the moment of the power stroke, the crankshaft rotation is from 360 to 540 degree. Last one, exhaust stroke. During the exhaust stroke, inlet valve is closed, exhaust valve is open, and the piston moves from bottom dead center to the top dead center. So due to the upward movement of the piston, whatever the burnt gases like carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen dioxide, it is all going out into the atmosphere through the exhaust. Okay, so during the exhaust stroke, crankshaft rotates 540 to 720 degree. Hence, we can say that here the 4-stroke diesel engine, it is works on diesel cycle and constant pressure heat addition cycle, and working cycle completed in 2 revolutions of the crankshaft. Okay, I repeat, what happens in case of the 4-stroke diesel engine? So the 4-stroke diesel engine, it works on theoretical diesel cycle, and it is also called as the constant pressure heat addition cycle, and your working cycle completed in 4 different strokes and 2 revolutions of the crankshaft. What happens during the suction stroke? Inlet valve is open, exhaust valve is closed. Piston moves from top dead center to bottom dead center. So due to the downward movement of the piston, suction is going to created inside the engine cylinder, hence only fresh air enters into the engine cylinder through inlet valve. Then at the end of the suction stroke, what happens? Inlet valve is also going to close, and during the suction stroke, crankshaft rotates 0 to 180 degree. Okay. Next, here the line AB, it represents the suction stroke in the PV diagram. Second one, compression stroke. During the compression stroke, inlet valve is closed, exhaust valve is also closed, and piston moves from bottom dead center to top dead center. Due to the upward movement of the piston, whatever the air present inside the engine cylinder, it is compresses to high pressure and high temperature, and at the end of the compression stroke, the pressure remains constant for the small displacement. Okay, and during that moment, compression stroke, crankshaft rotates 180 to 360 degree. That means line BC represents the compression stroke and line CD represents the combustion at constant pressure. Next, power stroke. So during the power stroke, both inlet and exhaust valves are closed, and at the beginning of the power stroke, the fuel injector spraying the diesel into the hot compressed air, hence diesel is completely burned and high pressure and high temperature is going to develop, that pushes the piston from TDC to BDC position. So during this moment, flywheel stores all the energy and supply the same energy during the suction, compression and exhaust stroke, and at the end of the power stroke, exhaust valve is open, hence sudden drop in pressure is going to take place, and crankshaft rotates 360 to 540 degree. Here line DE represents the power stroke and line EB represents the sudden drop in pressure. Okay, then exhaust stroke. So at the exhaust stroke, inlet valve is closed and exhaust valve is open, and piston moves from bottom dead center to top dead center. due to the upward movement of the piston, whatever the burnt gas is present inside the engine cylinder, it is going out through exhaust valve into the atmosphere. And here the exhaust stroke, it is represented by line BA and crankshaft rotates 540 to 720 degree. Hence we can represent here, in case of the 4-stroke diesel engine, it is also called as the diesel cycle, constant pressure heat addition cycle, and working cycle completed in 4 different strokes and 2 revolutions of the crankshaft. The next topic regarding to the today's session, it is called the difference between the 4-stroke petrol engine and the 4-stroke diesel engine. Okay, so we are already coming under the what is the working principle of 4-stroke petrol engine as well as the 4-stroke diesel engine. Now we are concentrating on the difference between the 4-stroke petrol engine as well as the 4-stroke diesel engine. Okay, so in order to know the difference between them, so I have made the 3 columns. The first column, it is regarding to the description or based on which the 4-stroke petrol engine and the diesel engines are categorized. Under that I have made the 10 points regarding that. First one, it is called theoretical cycle, the fuel used and charge drawn during the suction stroke, then admission of charge, then what will be the compression ratio, ignition of the fuel, thermal efficiency, power developed, noise and vibration, and the uses. Okay, we are going one by one. So first one, it is called theoretical cycle. So we are already discussed during the working of the 4-stroke petrol engine and diesel engine. So theoretical cycle of the 4-stroke petrol engine, it is called it as the Otto cycle. Okay, so theoretical cycle of the 4-stroke petrol engine, it is called Otto cycle, and it is also called it as constant volume heat addition cycle. Okay, it is also called it as constant volume heat addition cycle. Similarly, for 4-stroke diesel engine, it is called as diesel cycle. Okay, it is called as diesel cycle, and it is also called as the constant pressure heat addition cycle. Okay, so that means in case of the 4-stroke petrol engine, at the end of the compression stroke, the volume remains constant for the small displacement, hence it is called as the constant volume heat addition cycle. And in case of the 4-stroke diesel engine, at the end of the compression stroke, pressure remains constant for the small displacement, hence it is called as the constant pressure heat addition cycle. Second one, the type of fuel used. The type of fuel used in case of the 4-stroke petrol engine, name itself is saying it is called as the petrol, but in case of the diesel engine, the type of fuel used, it is called as the diesel. Okay, so this is regarding to the second one. And third one, charge drawn during the suction stroke. So what is the charge? It is called it as, in case of the petrol engine, it is called both air and petrol, it is called it as the charge in case of the 4-stroke petrol engine, but in case of the charge during the suction stroke for diesel engine, it is only air. Okay, the only air it is drawn during the suction stroke for considering the charge. Okay, then admission of charge, how the charge it is going to admitted. If you are considering the fuels like petrol as well as the diesel. Okay, so here the petrol it is enters into the engine cylinder during the suction stroke itself. Okay, here the petrol it is enters into the engine cylinder during the suction stroke itself. Okay, but in case of the 4-stroke diesel engine, at the end of the compression stroke. Okay, at the end of the compression stroke, the fuel injector spray the diesel into the engine cylinder. Okay, the charge, admission of charge, that is both air and a petrol mixture enters into the engine cylinder during the suction stroke itself, but the fuel it is sprayed, that means diesel is sprayed from the fuel injector into the engine cylinder at the end of the compression stroke or at the beginning of the power stroke. Fifth one, what is the compression ratio? We are already discussed what is meant by the compression ratio. Compression ratio, it is the ratio of total volume by clearance volume. So compression ratio in case of the petrol engine, it is 8:1 to the 12:1. That means here, in order to burn 8 particles of air, we required only 1 particle of petrol. Okay, to 8:1 to 12:1. But in case of the diesel engine, compression ratio it is very much high, that is 18:1 to 24:1. That means in order to burn 24 particles of air, only 1 particle of diesel, it is more than enough to completely burn. Okay, hence the compression ratio in case of the diesel engine, it is very much higher compared to the petrol engine. Okay, here comparatively less, okay, here comparatively more. Okay, so this is the another difference. Next one, ignition of the fuel. How fuel it is ignited? The fuel it is ignited in case of the petrol engine with the help of the spark plug. That's why it is also called as the spark ignition engine. Okay, it is also called as the spark ignition engine, that is SI engines. Okay, similarly, what happens the ignition of the fuel in case of the diesel engine? Here the fuel it is ignited when it is comes in contact with the hot compressed air. So that's why here the fuel it is ignited with the help of fuel injector when sprayed the diesel into the hot compressed air. That's why it is also called as the compression ignition engine. Okay, it is called compression ignition engine or CI engine. Okay, this is regarding to the another difference. Next one, thermal efficiency. Here the efficiency it is nothing but how much fuel is consumed in order to develop the particular amount of heat energy, that is called as the thermal efficiency. If the compression ratio of the petrol engine it is less, then thermal efficiency it is also going to less in case of the petrol engine comparatively to the diesel engine. Okay, next, power develop. So because of the less compression ratio, power develop it is also less in case of the petrol engine compared to the diesel engine. Okay, next, noise and vibration. So noise and vibration, because of the less compression ratio, it is also less in case of the petrol engine, but here the noise and vibration of the diesel engine, it is little bit higher compared to the petrol engine. Last one, uses. The uses of 4-stroke petrol engine, it is mainly takes place in motorcycle, car, etc. But the uses of 4-stroke diesel engine, it is mainly for truck, bus, tipper, etc. So these are the some of the important difference between the 4-stroke petrol engine and diesel engine. Okay, so next we are moving on to the last topic regarding to the today's session. It is called applications of IC engines. So internal combustion engines are mainly used in the transportation sector and power generation unit as well as the industrial equipment. Okay, so some of the important applications of the internal combustion engine, it is called automobile. That means internal combustion engines are mainly used in the automobile such as bus, car, truck, tractor, etc. for the propulsion. So in order to obtain the proper propulsion in these kind of vehicles, internal combustion engines are mainly used in the automobile purpose. Okay, so next one, second, it is called as the aircraft. What is the application of internal combustion engine in aircraft? Internal combustion engines are used mainly in aircraft such as small aircraft or small aeroplanes and helicopters for propulsion purpose. Okay, so for this propulsion purpose, so internal combustion engines are, it is also used in the aircrafts like small aeroplane as well as in the helicopter. Next one, marine application. So internal combustion engine, it is also used in the marine applications such as boat, ship and submarines. Okay, it is also used in marine applications such as boat, ship and submarines. And next one, it is called agriculture. The internal combustion engine, it is also used in the agriculture applications in order to run farming equipments. So what are the farming equipments or farming devices like tractor as well as irrigation pump. Okay, in order to run the irrigation pump and the tractors, internal combustion engines are also used. Next one, construction. The construction application, it is also required the internal combustion engines in order to mainly run bulldozers, excavators, etc. Okay, next, military application, internal combustion engine, it is also used in the military applications such as tankers and aircraft. And the last one, power generation unit. So internal combustion engine, it is also used in the power generation unit where we cannot locate the power grid system for running the various equipments. For example, in the remote locations we cannot provide the electricity. In those locations the power generation unit can be done with the help of internal combustion engine for backup purpose. So these are the some of the applications of IC engine. I repeat, so main applications of the IC engines are transportation, power generation and industrial equipments. Under that it is further categorized into automobile for running the bus, car, truck, tipper, etc. Aircraft, it is also used in the aircraft applications like small aeroplanes and helicopter for propulsion purpose. It is also used in the marine applications like running the boat, ship and submarines. Then agriculture purpose, that means running the farming equipments like tractor, irrigation pumps, constructions like bulldozers and excavators, military applications like tankers and aircraft, and the last one, power generation equipment where we cannot locate the electricity with the help of the grids. So then in order to obtain the backup purpose we are using the internal combustion engine. Thank you.